Welcome to a special episode of Bot Meets World. And today I'm going to be answering a question that I get so often. It's probably the most common question I've gotten from private equity firms, from venture capital firms, and from definitely from operating companies about how AI works. And I'll answer this question in a way that if you're very technical, it will make total sense to you. But also, if you're not technical, if you're just an aficionado of all things AI, this will also make sense to you. I think it's really important for all of us to understand the how about AI, not just read the headlines. And the question is, how do these document chatbots actually work? In other words, what you've heard about recently is an ability for us to ask a question of a big treasure trove of data and somehow have the AI respond. An example of this might be loading all your company's HR documents and policies into some kind of database and asking your new HR bot, hey, what is our policy for 401ks? And somehow it magically goes through all this endless data and comes back and responds in plain English, a very succinct, concise, and relevant answer. This also applies in the legal world, where you might have a law firm that asks its own internal chatbot, hey, what is our precedent for indemnification in cases related to creative artists or something along those lines? And again, the AI is able to go through all their past contracts and magically answer. And so today I'll walk you through how that whole thing is built, how that data pipeline is built, and hopefully coming out of this, you'll appreciate all these new chatbots coming out that I'm sure you'll see in the next couple of months in your workplace, regardless of where you work. So the first thing you need to understand is something called embeddings or vectorization. And so the best way that I found to think about embeddings is like a fingerprint. So imagine if I could give you any amount of text, any corpus of text. It's usually done at the scale of a paragraph or two, but whether it's a word, a sentence, a paragraph, or a page, if you feed that into this algorithm called the embeddings algorithm, it will spit back a list of numbers, a series of numbers. To be exact, it's about 1,532 numbers. These numbers can be decimals, positives, and negatives. But if you look at these series of numbers, these series of numbers form the fingerprint of that paragraph. And this series of numbers captures the intent. It captures the essence of that text, the context of that content. And if you can imagine if you had only two numbers like 4 and 5, plot them on an axis, on an XY axis, and that would show kind of a line, a vector of two dimensions. And so when you have 1,500 or so numbers, you can think about this as a 1,500 dimensional vector. Again, that's if you're mathematically inclined. If not, just think of it as a fingerprint. And the reason why it's helpful to think of it possibly as a vector is because when you have two fingerprints of two different pieces of context, how close these fingerprints are to each other actually relates to how closely related that content is. So for example, the word hot and the word dog probably don't have vectors that are, or embeddings or fingerprints that are very close together. But the embedding or vector of the phrase hot dog would actually be fairly close in the same vicinity as the embedding of the word sandwich, because those two have a similar intent behind them. So again, to review, today we are able to take any piece of content, any amount of words, any language, any paragraph, any page, feed it through this embedding algorithm, and it will spit out a series of numbers. And these series of numbers is like a fingerprint. And if you can compare two fingerprints of two different pieces of text, the distance between those fingerprints or the similarity of those fingerprints is related to the similarity of the context and content and the intent of the text behind them. So that's part one. That's very important to understand. And so what happens firstly is when all these documents are loaded into the AI, what's actually happening is they are chunkifying or reducing all those big documents into small pieces of text. Usually this is done at the paragraph level or the page level. So if you can imagine thousands and thousands of pages of HR documents, they reduce them into tens of thousands of individual paragraphs or chunks of text. And these chunks overlap a bit. But the point is that each chunk is then removed and put into a database. And that chunk is also vectorized. In other words, we get the embedding of that chunk. So now, again, to recap, we've taken all of our data, right? We've broken it up into small digestible chunks. And we like paragraphs because usually a paragraph is one kind of content, right? It's one thought or one idea. So again, we've taken all these documents, all of these text, broken it down into individual paragraphs or chunks, and we've gotten the embeddings or those fingerprints of all of those chunks. All right. Now we're going to store all those chunks and their fingerprints in something called a vector database. All you have to know about this is that a vector database is optimized for handling one kind of data type. And that one kind of data type is these fingerprints. So a vector database is just a massive collection of all these individual vectors, all these individual fingerprints. Great. All right. Now here comes putting it all together. When you ask a question of this HR chatbot, when you ask, what is our policy for 401ks? The first thing it typically does is it creates an embedding or fingerprint of your question. And then it looks for the chunks in the database whose embeddings are most similar to the embedding of your question. Again, it goes through and checks all those fingerprints of all those different chunks and finds the chunk that is most closely related to your question. And it usually does this through, again, for those who are mathematically inclined, there's an algorithm called cosine similarity, which is a very efficient way to go and compare tens of thousands or millions of vectors. And once it does that, it surfaces or it gives you a result set of, let's say, the top 2, 3, 4, 5 chunks that might be related to your question. And then it takes your question, and it feeds your question plus these 3 to 5 chunks into your standard kind of ChatGPT style large language model. And based on your question and based on these possible answers that relate to your question, now the large language model, like ChatGPT, is able to synthesize or form a coherent, cohesive answer to your question based on those facts we've gathered from the database. All right. So at this point, you understand how we create these fingerprints. You understand that we create fingerprints for all of the chunks of all of the documents we have. And then we, based on the fingerprint of the question and the fingerprint on all the chunks, we bring together the most relevant chunks very quickly and synthesize from those chunks the answer. And that's how this stuff works. Now, before we finish, I'm going to give a few more reasons of why this style of pipeline works and why it might be better than something known as fine-tuning. So another way that you could potentially do this is you could fine-tune an entire model based on all these documents in your repository. So the same way as these base large language models like ChatGPT were trained on all the documents in the internet and found the different patterns and found the facts in the same way that ChatGPT is able to answer your questions about all sorts of random facts in the world, you could expose and you could train kind of a ChatGPT 2.0 or 3.0 specifically on the data in your HR repository. The reason why that's efficient and good is that it could respond immediately. It wouldn't need that extra step of creating the embeddings, of finding the closest chunks. And so it feels more efficient. But the problem is that large language models hallucinate, as you know. In other words, they don't always respond accurately. They have some sense of creativity to them. And when you have lots of different, potentially conflicting pieces of answers in your data repository, like if you have 20 possible legal cases that might relate to the question, you don't know which of those 20 or which synthesis of those 20 the large language model would be using to answer your question. So using embeddings gives you auditability. In other words, when you use the chatbot and you construct the pipeline in the way that I originally explained, along with the answer, you can also surface those 3 or 5 chunks that were used to create the answer. And so now the attorney or the HR professional who's asking the question not just gets the final answer, but they can also look at the source that was used to synthesize the answer. And you can include a manual process that allows a professional to kind of weed out sources that they don't like or sources that they know are just not relevant. And having that auditability, having that traceability is really important for mission critical tasks, especially when you think about legal cases or healthcare or HR. So now you understand how these chatbots are built and you understand why they're done using embeddings and vector database search rather than just fine tuning a model. Hopefully that helps. And if you have any questions, always reach out. If you have any other topics that you come across in the land of AI that don't quite make sense, shoot me a DM, shoot me an email, and I'd be happy to dive in and explain it to you guys. All right, take care.